Have you ever wondered about the very nature of the universe and where we, as humans, fit into the grand scheme of things? We look up at the night sky, seeing billions of stars, distant galaxies, and countless planets, yet it's almost impossible to fathom how all of this came into being. The more we learn about the cosmos, the more we realize how little we truly understand. From the birth of the stars to the formation of galaxies, and ultimately to the existence of life itself, the story of the universe is more awe-inspiring and complex than we could have ever imagined. But, despite the overwhelming scale of the cosmos, scientists like Brian Cox believe we are on the verge of understanding it all. When Brian Cox talks about the nature of space, he reminds us that in exploring the vastness of the universe, we aren't just investigating distant galaxies or studying the light from faraway stars, we are looking back at our origins. We are, in fact, the offspring of stars, each of us forged from the same cosmic dust that makes up everything in the universe. Before the Big Bang, there was a state of existence that was almost incomprehensible, a condition that defies all logic and human experience. Yet, it's from this inexplicable beginning that everything we know today came into being. One of the key points Cox often emphasizes is how difficult it is for human minds to grasp the magnitude of the event that led to the creation of everything. The universe, in all its grandeur, is still a great mystery. Stars, galaxies, black holes, and the billions of planets scattered across space make us realize just how small our Earth really is. Despite our planet being a tiny speck in the vastness of space, we find ourselves trying to make sense of everything, from where we came from to why we're here. These questions are as old as humanity itself, and yet, they remain unanswered, despite centuries of exploration and discovery. In recent years, however, our scientific tools have allowed us to peer deeper into space than ever before. Telescopes and satellites like the James Webb Space Telescope are now providing us with unprecedented views of the universe, revealing new galaxies, stars, and even clues about the earliest moments after the Big Bang. But each new discovery only seems to raise more questions. The deeper we look, the more complex and mysterious the universe becomes. It almost feels as though the universe is playing a game with us, responding to our inquiries in ways that make us question everything we thought we knew. Despite this sense of mystery, Cox remains optimistic. He argues that the universe, while certainly full of secrets, is not an unsolvable puzzle. In fact, it's a mystery that is well within our ability to understand. The key, he believes, is in looking carefully at the stars, at the galaxies, and at the very building blocks of reality itself. So what do we really know about the universe, and what do we still need to learn? Can we truly begin to understand the origins of everything that exists? To explore these questions, we first need to confront one of the most fundamental mysteries of all, the origin of the universe. For centuries, humanity has tried to answer the question, where did everything come from? The Bible's creation story, for instance, tells us that in the beginning, there was God, and He created the universe out of nothing. Let there be light, it says, and in that moment, light was created. But what if science tells a different story? According to the current scientific consensus, based on the Big Bang theory, the universe began as a singularity, a point of infinite density and heat. The Big Bang wasn't an explosion in space, but rather, an explosion of space itself, and from that moment onward, everything began to expand and evolve into the universe we know today. However, one of the most profound ideas that has emerged from modern cosmology is that the earliest moments of the universe were not just dark but devoid of light altogether. For millions of years after the Big Bang, the universe was too hot for light to travel freely, and so, space remained shrouded in darkness. This period is often referred to as the cosmic dark ages, a time when the universe was essentially a featureless void. And for a long time, scientists thought that this darkness would remain beyond our reach, beyond our ability to study or observe. But then came the James Webb Space Telescope, a piece of technology that has completely transformed our understanding of the universe. Webb has the unique ability to observe the very early moments of the universe, looking back more than 13.6 billion years in time, almost to the very moment of the Big Bang itself. What Webb revealed, however, was a complete surprise. Contrary to what we had thought, the early universe wasn't entirely dark. Instead, Webb's images showed us galaxies already forming just a few 100 million years after the Big Bang. This finding is a significant challenge to our previous assumptions about the universe's early history. Could it be that the universe was never entirely dark after all? This discovery has profound implications. If galaxies and stars began forming so soon after the Big Bang, it raises new questions about the process of cosmic evolution. Was there light in the universe from the very beginning? If so, what did it look like, and how did it evolve over time? These are the questions that scientists are now trying to answer, but each new answer seems to only lead to more questions. The mystery of the universe's origins is far from solved, and it's clear that we still have much to learn. At the heart of these questions is the nature of light itself. Albert Einstein's theory of light, which proposed that light is made up of particles called photons, has fundamentally shaped our understanding of the universe. Light, in this view, is more than just what we see. It's a form of energy that interacts with the particles of matter in complex and fascinating ways. But the nature of light goes far beyond our everyday experiences. Light isn't just something that we see with our eyes, it's a fundamental force that governs the interactions of the universe, from the creation of stars to the development of life. Yet, as Richard Feynman famously said, if quantum mechanics hasn't stunned you, you haven't understood it. Quantum mechanics reveals that light isn't just a wave or a particle, it's both at the same time. It's an idea that defies our conventional understanding of reality, where particles can exist in multiple states at once until they are observed, at which point they collapse into a single reality. In the quantum world, particles behave in ways that are both mind-boggling and counterintuitive, yet they are the building blocks of everything we experience. Feynman's insights into quantum physics point to a deeper understanding of the universe, one in which everything is connected, and where the smallest particles of matter can exist in multiple states at once. This idea challenges everything we think we know about the nature of reality, and it opens up the possibility of exploring alternate dimensions, universes, and even timelines. Could it be that the universe we know is only one of many possible realities, each with its own set of rules and possibilities? These ideas may sound like science fiction, but they are grounded in the very principles of quantum mechanics. At the same time, there is another fundamental question that continues to elude scientists: where did all of this matter come from? According to Einstein's theory of relativity, the universe began as a singularity, a point of infinite density. But if nothing could exist before the Big Bang, what, then, did the singularity emerge from? This paradox lies at the heart of one of the most profound mysteries of modern science. Physicists have proposed various theories to explain the origin of the universe, but none of them offer a definitive answer. Some suggest that the universe may have emerged from a quantum fluctuation, a random fluctuation in the fabric of space-time that gave birth to the Big Bang. Others propose that our universe is just one of many in a multiverse, a collection of universes that exist simultaneously, each with its own laws of physics. These theories are difficult to prove, but they provide tantalizing glimpses into the possible nature of reality. The idea of a multiverse, in particular, raises profound questions about the nature of existence. Could there be countless other universes out there, each with its own laws and possibilities? And if so, what does that mean for our understanding of reality and our place within it? The quest to understand the origins of the universe is far from over, but it has already revealed some astonishing insights. Through the work of scientists like Brian Cox, we've begun to glimpse the deeper truths of the cosmos, and we're learning that the universe is far more mysterious and awe-inspiring than we could have ever imagined. From the light that fills the cosmos to the quantum fluctuations that give birth to reality itself, the universe is a vast and intricate web of phenomena, each part connected to the other in ways that we are only beginning to understand. But there's still so much more to explore. The James Webb Space Telescope has shown us that the universe is not a static, unchanging place. It is a dynamic, ever-evolving system, filled with mysteries that continue to challenge our understanding. Every new discovery brings us closer to answering some of the most profound questions of all: where did we come from? What is our place in the cosmos? And what lies beyond the limits of our understanding? As we continue our exploration of space and time, we will undoubtedly encounter more surprises and more mysteries that defy our comprehension. But with each step, we draw closer to unlocking the secrets of the universe, secrets that may one day reveal not only where we come from but also where we are going. The journey is just beginning, and the possibilities are endless.